Hello, today we're going to be covering 7.2 hypothesis testing for the mean with a standard deviation known for the population. Our SWABAT is going to be find and interpret p-values. Use p-values for a z-test for a mean of mu when the standard deviation is known. Find critical values and rejection regions in the standard form distribution, and use rejection regions for a z-test for a mean mu when the standard deviation is known. Key thing here is the standard deviation is known. I'm going to let you please press pause as you read through these because I won't read through the whole thing for you all. I'll just give you a couple of highlights. However, in case you are a little rebellious and you don't feel like pausing to read the whole thing, this kind of critical. You're going to need to know that. Probably highlight it, put it somewhere like on a cheat sheet or something. Okay, Moss, what else? Z-test, I would also kind of know this. We'll probably do most of this on our calculators though, but if you didn't have your graphing calculator, you could use this formula. If you are going to be using your graphing calculator, which I am as well, please do me a favor, really do press pause right now and get it, because I'm going to be talking you through some very important steps. These are the steps that we will use over here. What else would I highlight? This is life. Please highlight it, underline it. Whenever you're doing your homework, have that out because it's a wonderful shortcut that's going to help us do some things that are pretty great. What else? Yeah. This is kind of important because this is how we're going to be making our decisions. And one thing I want you to know or remember from here, this part right here, whenever we do our bell curves, there's going to be a part that's shaded, because it's either going to be a left tail test or a right tail test or a two-tail test. And we will always, always, always reject the shaded region. We'll always reject the shaded region. That's something to remember, that we will always reject the null hypothesis, excuse me, if it's in the shaded region. So note that as we go through these exercises. Alright, so keep this out. Another thing, if you are grabbing materials now that you're going to want to have out, is your standard normal distribution chart so that we can look up some z-scores. Not a lot, but a couple, 2, 3. So have this out as well, please. Okay, so looking at the first example, for our notes here, we have the p-value for hypothesis test is shown. Use the p-value to decide whether to reject the null hypothesis when the level of significance is A, 0.01, 0.05, or 0.10. So one of the things that I had you highlight from your previous one or underline was this statement right here. So let's write this at the top of our papers. If p is less than or equal to A, which is actually alpha, then we will reject the null hypothesis. If p is greater than A, then we will fail to reject the null hypothesis. And just as a reminder, the null hypothesis is the one that has the equal to, so less than or equal to, greater than or equal to, or just straight equal to. Okay, so let's do some comparisons then. So remember, if it's less than or equal to, reject. If it is greater than, then we will fail to reject. So what are we comparing? My p for this one is 0.0691, and the first one for alpha is 0.01. So we have to compare the two decimals. This is what you did like in elementary school or something. Which one is greater than, which one is smaller than? Well, this is greater than that. So one thing I kind of always do is remember that my arrow should point to the smaller number. And so right now it's pointing to the smaller number. And so this is this category right here, because the p is greater than alpha. So I'm going to fail to reject the null. Same thing, so we're still comparing the this is for part A, excuse me, 0.0691, and we are now for part B comparing it to 0.05. Well, this is smaller, so my arrow is going to point to that. And so therefore I'm in another fail to reject the null hypothesis. One more. 0.0691. I know what you're thinking. There's got to be one reject. 0.1. And this would be it because this is smaller. Less than or equal to, therefore I am in the reject area. I'm going to reject the null hypothesis. Okay, we're building here, so stick with me. So for our next one, our question is find the p-value. So this time they don't give me the p-value. This is what we're building. We're going to have to find it ourselves. Not a problem. We can do that. With the standardized statistics, decide whether to reject for the level of significance alpha. This is a left-tailed test. And so what I need to know, and another way, this is right here, this negative 1.55. I need the p-value for that. So to get the p-value, you're going to go to your chart, negative 1.55, and then look it up, negative 1.55. You're going to have to trust me because I can't show you both of those at the same time. And on that, I find that the p is equal to 0.0606. So if that's my p-value, I'm comparing that to the level of significance that they're asking me for, 0.05. 0.05. And what could we say about that? Well, this is definitely greater than that, so I'm going to fail to reject. The null hypothesis. All right, there you go. So next part, that's based upon just given values, p-values in the level of significance. What we're going to do next is to match up the p-value with the graph that displays without any calculations. So I don't want to find the z-score here and find the z-score. I just want to look at it and tell. So I'm looking at these two graphs, and this one has a larger shaded area, if you can see that. This one has a larger shaded area. That, to me, tells me that this should be the larger p-value. So which one has the larger p-value? It looks like this one does, at 0.2802. And this one, because it has a smaller shaded one, should go right here. So I would say for p is equal to 0.0688, that would go with graph A. And for p is equal to 0.2802, that would go with graph B. So you're looking at the shaded one. Whichever one has a larger shade area, that's your p-value. Okay, so now, before I show you how to do these things in your graphing calculator, let's talk about what the calculator might look like. So use the TI-84 display to make a decision to reject or to fail to reject the null hypothesis at a level of significance of alpha 0.01. So there's two ways to look at this, and I'm going to kind of introduce you to, well, first of all, here's what we've been doing. And then we have to compare the 0.006, I'm rounding off, and then I would have to compare that to 0.01. And then you're going to look at it and you're going to say, okay, well, in comparison, this is way smaller than that. Therefore, I'm going to reject the null. But this is kind of hard to remember for a lot of people, and sometimes it works a little bit better with something visual that we kind of just look at. So look at the information and let's look at the entire screen. This right here is telling me that it's pointing to the right, and therefore we have a right-tailed test. Remember, that's based upon the alternative hypothesis. And so if this is right-tailed, I'm here, and the z-score for this is 2.48. 2.4, is that what it is? 2.486, 2.486. I really don't need that many numbers, but it's fine. So this is my rejection area. They're saying reject everything to the right of this z-score. So this is where the other part that I told you was important will kind of come into play, and I want you to stay with me even if you like this part, this method, because we use this a lot more, to be honest with you. So with the alpha being 0.01 and this telling me that it's a right-tailed test, that puts me here, alpha 0.01. So you're looking at alpha 0.01, right-tailed 2.33. 2.33. I was just kidding. That is this part, 2.33. I know, you're irritated, but that's okay. 2.33. This tells me where my rejection area is. Always, always, always. This tells me that my score is 2.49 approximately. So this is outside of that. This is in my rejection area. We always reject the shade. So it's going to be a reject the null hypothesis for that one. All right. Foundation has now been laid. Let's continue. Find the critical values and the rejection. So if we don't have that chart, we're going to have to do this ourselves. And so, transitioning more into this, my alpha, this is a right tail test, so I'm going to be over here. I know that this is composed of 0.08. I need a z-score for this number. The problem is, when you look it up on your chart, you're not really looking for 0.08. You're looking for, because these charts give you the area to the left of it. So I don't want to look up 0.08. I want to look up this amount to the left of it, which is 0.92. I don't know what that is by heart. So you're looking it up, 0.092. And you're looking for what's closest to 0.92. Is it 0.9207 or 0.9222? I'm going to go with this one right here, which would put me at 1.41. 1.41. 1.41. So we're going to reject anything that has a z-score that's greater than 1.41. That's my rejection region. Anything with a z-score that's greater than 1.41. And that is what these come from. This is how you would do it for yourself, but these are the common ones that we use most frequently. But if you had to, you could figure it out on your own. Alright, so now, based upon that, you're basically going to find out what you're going to do here. Are you going to reject or not so much? You're given a graph, and the first one is z is 1.98. So I'm looking for that 1.98. Well, this is 1.96. So for part A, you barely fit in there. But this is where A lies, which is in the shaded area. If it's in the shaded, because here's 1.96 and 1.98 is just after it, I'm going to reject. For your next one for part B, you have negative 1.89. That's right before negative 1.96. So that's not in the shaded, so I'm going to fail to reject it. Take a moment and press pause and then check your answers for the last one. Just do those right quick. Alright, so go ahead, check your answers with mine, make sure that you match up. I put C right around there, and then D was right there, barely in there, but it is still in the shaded area. Thanks. So as we reach the next portion of our notes, you will need your graphing calculator, so go ahead and grab that, and then continue on to the next video. Thank you.